Hello and welcome to today's math tutorial. My name is Zach Watson. I'm a high school math teacher. I teach geometry and algebra 2. Today I'm going to be working through problem number 28 on page 219 of the Glencoe McGraw-Hill geometry book. So we are solving for the distance between two parallel lines. So right here I have my 3x plus y equals 3 and y plus 17 equals negative 3x. What I'm going to do from here is I want to start out by putting both of these into slope-intercept form. So I want to get y on its own. I'm going to try to go on the left side. So I can start by here. I can say I can subtract 3x from both sides. I'm going to end up with y equals negative 3x plus 3. And over here, I have y on its own already. I'm just going to subtract 17 from both sides. I'm going to end up with y equals negative 3x minus 17. So as we can see here, that means they're going to be parallel, as they have the same slope. They just have different y-intercepts. So I'm actually going to use a little bit of color here.
Start out with my x and y axis.
Negative 3x plus 3. So this is going to be my green one. So negative 3x plus 3. Start with 3. Negative 3x is going to look like this. So if you're watching this at home, I recommend doing this yourself. The way I'm fairly easily drawing my line is I'm starting with my y-intercept at 0, 3. And then I'm saying if my slope is negative 3 over 1, rise is negative 3, run is 1, so negative 3, 1, negative 3, 1, negative 3, 1, and so on. All right, and for my other equation here, got y equals negative 3x minus 17, so come down here, 1, 2, 3, 4, 5, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, all the way down here. Oh boy. So we're coming all the way down here, and I'm going to do the same thing. So now I don't really need to draw down here, so I'm going to bring this back up. So I can go to the left, and then I'm going to go up 3. I want to make sure that I'm hitting each. So notice I'm going over 1, up 3. All right. And now I want to calculate what is the distance between these two lines. I'm actually going to use a different color here. Got this kind of blue color. So I want to make another equation. So I see these right here. This is my slope. So to find a perpendicular line that'll give me the distance between the two, I want the negative reciprocal of this. So the negative is going to be 3 over 1. And the reciprocal of that is going to be 1 over 3. So I know my equation is going to be y equals 1/3 x plus b. Now, if I look ahead at this, I know that if I go something like this, I could have 1/3 x plus 3, which will definitely go through that point. So I'm going to do that, plus 3. So I know that I'm going to have to, at some point, find 2 points. So if I use this point right here, which I already have defined, I already know that it exists on this green line, that saves me half the work. If I were to choose 2 random points up here or down here, I'm gonna have to solve for both of those and figure out what my equation is. But this makes it a little bit easier for me. So since we went 1 over 3 up, now I'm gonna start with this point, and I know it's going to go 1 up and 3 over. 1 up, 3 over. Same thing in the other direction. 1 up, 3 over, 1 up, 3 over. All right, so I'm going to end up with a line that looks like that. So, assuming I drew my picture correctly, this right here should be a right angle. And I have enough information now. I want to solve for what is this point over here. So if I set, now, if you drew it on graph paper, which I recommend you do, I would say pause it and do this now if you have not gotten this far. I would say you should be able to have a pretty accurate point right there. In fact, I'm going to guess that this is 1, 2, 3, 4, 5, 6, that this is -6, +1. But I'm going to check by setting my blue line equal to my red line. So my blue line is 1/3 x plus 3. I'm going to say that's equal to -3x minus 17. So I'm going to solve for x here. Oh, students are about to come. I'll finish this later. So let's solve for x. So as we're about to solve for x here, we're now going to have the x, whoops, -1/3 x. So we're gonna solve for what is the x coordinate of over here when we do that. All right. So add 3x to both sides. I have 3 and 1/3 x. Subtract 3 from both sides. Those will cancel. These will cancel, and I'm left with -20 over, just kidding, just -20. And this is going to be equal to 10 over 3x equals -20. If I multiply both sides by 3 over 10, 3 over 10, I'm going to end up with, those are going to cancel, x equals, and then -20 divided by 10 is going to be -2 times 3. X equals -6. That sounds about right. 1, 2, 3, 4, 5, 6. Good. All right. Plug that back into, I don't know, I think this one looks a little easier. Y equals -3. Plug in the -6 minus 17. I'm going to have +18 minus 17. Y equals 1. I like it. All right, so that means this right here is -6, 1. I now have this coordinate, and I have this coordinate. I now have enough information to solve for the distance of this blue from the blue-red intersection to the blue-green intersection. So I could use the distance formula. I could also use a little bit of visual common sense here and use the Pythagorean theorem. So I got 1, 2 over, and then 1, 2, 3, 4, 5, 6. So if I have that, I have a right triangle. I know this is going to be 2 units, and I know this is going to be 6 units. So I'll do this first to check this way. So I got 6 squared plus 2 squared. 6 squared plus 2 squared is equal to, this is going to be my distance squared. I'm going to say d squared. So 36 plus 4 equals d squared. And this is going to be 40. So square root of 40 equals d. So I just jumped and said the square root of both sides. So d equals square root of 40, or it should be about, it's going to be a little bit bigger than 6, a little smaller than 7. So I would say about 6.3. I'm just guessing that from my head. Now, the other way to do it is use your distance formula. So we got the square root of, and then I have -6, 1. So I got x2 minus x1 squared plus y2 minus y1 squared. x2, I'm going to say, let's see. I'm going to say that this is my x1, y1, x2, y2. So x2 is -6 minus x1, 0 squared, plus y2 is 1 minus y1 is 3. I'm going to end up with -6 squared plus -2 squared. And that is the same as 36 plus 4 is equal to root 40, just like I'd gotten before. So my final answer is going to be about 6.3, and we can kind of check our answer. Look, it's going 1, 2, 3, 4, 5, about 6 units. So it's going to be, yes, definitely a little bit greater than 6. We can't quite tell how much more, but our answer looks accurate. About 6.3, could be 6.4. Let's do it with a calculator real quick. Let's see. Square root. So if you hit second and then the x squared key and then you put 4, 0, gonna come out to 6.32. That's it. Thank you for watching. Thank you for using me as a resource. I hope that helped you solve any problems you were having about finding the distance between two parallel lines on a coordinate plane and using the distance formula and using a system of equations to find a point, and how to use a picture to help you come to a solution a little bit quicker. Thank you for watching. Let me know in the comments what else you want to post, especially if it's from the book. Maybe it's a homework problem, and stay weird.